Dear students, now we are going to see crossed Cannizzaro reaction. Two different aldehydes, they are not having alpha hydrogen atom and they are the non-enolizable aldehydes can undergo auto-redox reaction in the presence of concentrated sodium hydroxide or potassium hydroxide. We are getting two compounds. One is the primary alcohol, another one is salt of carboxylic acid. Primary alcohol is the reduced product and salt of carboxylic acid is the oxidized product. We have known aldehydes can undergo oxidation and reduction. So aldehydes on oxidation we are getting an acid and thus on reduction we are getting a primary alcohol. That's why in the case of crossed Cannizzaro reaction we are getting two products. One is the oxidized product, that is an acid, another one is the reduced product, that is the primary alcohol. Here we are getting acid as a salt of acid, salt of carboxylic acid. Now we have two aldehydes. So which one is undergoing oxidation and which one is undergoing reduction? That is, the more reactive aldehyde can undergo oxidation and the less reactive aldehyde can undergo reduction. That is, the lower aldehydes can undergo oxidation to form salt of carboxylic acid, whereas the higher aldehydes can undergo reduction to form a primary alcohol. So we have two types of aldehydes. One is an aliphatic aldehyde, another one is an aromatic aldehyde. Which is more reactive? Aliphatic aldehydes are more reactive than aromatic aldehydes. Why? Because the aromatic aldehydes know they are having resonance structures. So because of the resonance, the nucleophiles will not attack easily. Whereas the aromatic aldehydes know they are not having any resonance structure. That's why the nucleophiles will easily attack. Now we'll revise about Cannizzaro reaction. Already we have seen this. What is Cannizzaro reaction? Two aldehydes without alpha hydrogen atom can undergo auto-redox reaction in the presence of concentrated sodium hydroxide or potassium hydroxide. We are getting primary alcohol and salt of carboxylic acid. So for the case of Cannizzaro reaction also we are taking two aldehydes. For Cannizzaro and crossed Cannizzaro we have taken the starting material as two aldehydes. In the case of Cannizzaro reaction the two aldehydes are the same aldehyde. So we are taking two molecules of the same aldehyde, whereas for crossed Cannizzaro reaction we are taking two different aldehydes. That is the major difference between these two reactions. Now we'll see the reaction for crossed Cannizzaro reaction. So here we have taken two different aldehydes. One is the formaldehyde, another one is the benzaldehyde. So here this undergoes auto-redox reaction in the presence of concentrated alkali. We are getting two products. One is the oxidized product, another one is the reduced product. Which has to undergo oxidation? That is, the lower aldehyde has to undergo oxidation to form a salt of carboxylic acid. So here we have the formaldehyde. So formaldehyde on oxidation we are getting formic acid, but here we have to get the salt. That's why we are getting the salt of carboxylic acid as sodium formate. Another aldehyde is benzaldehyde that has to undergo reduction. So here the aldehyde part would be reduced and we are getting a primary alcohol, and that is called as benzyl alcohol, that is having the primary alcohol group CH2OH. So now we are going to see the mechanism for this reaction. So mechanism is similar to that of Cannizzaro reaction. So first step is the nucleophilic attack by the hydroxyl ion on the carbonyl carbon. So now we have taken that formaldehyde that is added with the hydroxyl ion. So this reaction is a fast reaction. So here the hydroxyl ion is going to add with the carbonyl carbon. So the hydroxyl ion is going to add with the carbonyl carbon. So because of that addition, what happens? The bond between carbon and oxygen, actually that is connected by means of double bond. So that would be broken and that should be converted to single bond, and oxygen is getting a negative charge. So bond becomes negative charge and we are getting an alkoxide. So and we are getting an alkoxide. So this alkoxide is otherwise called as a hydroxy alkoxide or a tetrahedral anion. Now in the case of the carbonyl group, this oxygen, no, that is electronegative in nature. That's why that is having the tendency to withdraw electrons from this carbon. That's why the carbon is getting a positive charge and making it as a electron deficient one. Now this OH group, no, that is a nucleophile. That's why that is going to attack the carbonyl carbon and forming a COH sigma bond, COH single bond. So like this, COH single bond. So in the case of the carbonyl group, the oxygen is electronegative in nature. So that is having the tendency to withdraw electrons from the carbon. So that's why carbon is getting a positive charge and, and it is making as an electron deficient one. Whereas the hydroxy group we have seen, no, that is going to add with this. So that hydroxy group is a nucleophile. So that is going to attack the carbonyl carbon. And what is formed there? COH single bond we are getting. So COH sigma bond we are getting. Now second step. Second step is the hydride ion transfer. Now in the first step we are getting one alkoxide. No? So with the alkoxide what is added? Another aldehyde would be added. What is the another aldehyde? That is benzaldehyde. This reaction is a slow reaction and that is a rate determining step. So now here what happens, actually oxygen is getting a negative charge, no? So negative charge becomes bond. That's why oxygen would be connected to carbon by means of double bond. So now think about the valency. Already this is 4. Because of the formation of one more bond, what happens? Valency would not be satisfied. That's why the hydrogen has to go there and has to connect with the carbonyl carbon. Now the valency would not be satisfied. That's why bond becomes a negative charge for this oxygen. So we are getting two products. One is the formic acid. So this is the formic acid, this part, formic acid. Another one is an anion. So negative charge becomes a bond. That's why the hydrogen is moving from here and that is going to add with the carbonyl carbon of another aldehyde. Here this double bond becomes negative. So oxygen is getting a negative charge. We are getting two products. One is the formic acid and another one is an anion. Now third step. Third step is called as acid-base reaction, or we can tell it as a proton transfer, transferring of proton. So now we got two products in second step. No, they are formic acid. Another one is an anion. So with these two we are adding sodium ion. By the addition of sodium ions, what happens? Sodium is going to add with the, so this sodium is going to add with the formic acid and we are getting a sodium formate. That's why the hydrogen present here, no, that is going to add with this oxygen and we are getting a benzyl alcohol. So we are getting sodium formate. Another one is benzyl alcohol. So these are the two products we got from this crossed Cannizzaro reaction. Now we are going to see example 2. So here we have taken two aldehydes. One is benzaldehyde, another one is para-nitrobenzaldehyde. That undergoes auto-redox reaction in the presence of concentrated alkali. So here this nitro group is an electron withdrawing group. That's why this aldehyde has to undergo oxidation. So on oxidation what happens in this group, I mean this structure, no? So this has to undergo oxidation and this would be reduced. On oxidation, this aldehyde would be converted to acid, that is sodium salt of acid, and on reduction this would be converted to a primary alcohol. So we are getting one oxidized product, that is this one, and one reduced product. So this is benzyl alcohol, reduced product, and that is having the primary alcohol. So now we are going to see the applications of this reaction. So first we have taken acetaldehyde. What is acetaldehyde? CH3CHO. That is acetaldehyde that is having alpha hydrogen atom. And that has to react with the 3 molecules of formaldehyde, that is not having alpha hydrogen atom. This undergoes crossed aldol condensation. On crossed aldol condensation, so here we have 3 formaldehydes, no, that is how formaldehyde would be written? HCHO. So instead of that, we can write CH2O. So that 3CH2O would be connected to these 3 hydrogens, and that should be converted to CH2OH. So we are getting the product like this. So this is called as trihydroxy. So trihydroxypivaldehyde. Now this trihydroxypivaldehyde, that is not having alpha hydrogen atom, that has to react with the formaldehyde. So now we have two aldehydes, one is formaldehyde, another one is trihydroxypivaldehyde. Both are not having alpha hydrogen atom. That's why that has to undergo crossed Cannizzaro reaction. On crossed Cannizzaro reaction, one has to be oxidized and one aldehyde has to be reduced. So here this is the lower aldehyde. Formaldehyde is the lower aldehyde. That's why this would be oxidized and we are getting a sodium salt of formic acid. That's why we are getting sodium formate. And for this case, this should be reduced. That's why instead of this aldehyde, we are putting a primary alcohol there. So that is the reduced product. So we are getting the reduced product as this one, that is called as pentaerythritol, and oxidized product as sodium formate. So now we'll see the second application, that is preparation of various alcohols and acids. Now we are taking two molecules of glyoxylic acid that undergoes Cannizzaro reaction. So we are getting two products. One is sodium oxalate, another one is sodium glycolate, that is one aldehyde. So here we have this aldehyde, no? So one would be oxidized and another would be reduced. So we are getting sodium oxalate, another one is sodium glycolate. Sodium oxalate is the oxidized product and sodium glycolate is the reduced product. Now we'll see the limitations of crossed Cannizzaro reaction. Sometimes this reaction fails because of the steric hindrance. Because of the presence of the bulkier group, this reaction may fail. Example is ortho disubstituted benzaldehyde. So that's all about the crossed Cannizzaro reaction. Thank you.